Chapter 10. Creating Algorithm and Flowchart. Important points. 1. Algorithm. 2. Flowchart. 3. Creating a flowchart. Hello children. All of you know that to complete any task, we have to proceed step by step. The stepwise procedure helps us to complete the task efficiently. Let's learn to draw flowcharts and algorithm which work according to the stepwise instructions. Algorithm. All the programs are written in a special language known as computer language. Before writing a program, we have to first determine the objective and then begin to write the steps to implement it. The step-by-step procedure of determining the objective is known as algorithm. So we can say that an algorithm is a representation of a solution to a problem. We solve many such trivial problems every day without even thinking about them. For example, preparing breakfast, traveling to the workplace, etc. Let us take a daily life example. Steps to go to a shop to buy toffees. 1. Take money and go to the shop. 2. Tell the shopkeeper about the brand of toffees you want to buy. 3. Take the toffees from shopkeeper. 4. Pay the money to the cashier. 5. Take the balance if any. 6. Take the bill. 7. Finally, you receive the desired product, that is, the toffees. Rules for writing algorithms. There are some guidelines for writing an algorithm. 1. Give statement numbers as 1, 2, etc. 2. Always begin with start. 3. Write each instruction on a separate line. 4. Write function of each statement in a separate line. 5. Write stop at the end of the algorithm. Examples of an algorithm. Example 1. A recipe to make vegetable soup. 1. Start. 2. Collect all ingredients. 3. Rinse the vegetables. 4. Wipe the vegetables. 5. Finely chop and slice vegetables accordingly. 6. Heat oil in a pan. Add onions and garlic. Then add the chopped mixed veggies. 7. Saute them on a medium flame for 4 to 5 minutes. 8. Add the moong sprouts and stir well. 9. Add water and stir. 10. And serve it hot. 11. Stop. Example 2. To make butter toast. 1. Start. 2. Cut one slice from end of the loaf of bread. 3. Put slice of bread into toaster. 4. Turn the toaster on. 5. Wait for the toaster to finish. 6. Put toasted bread onto a plate. 7. Spread butter on the toast. 8. Stop. Algorithms are often broken down into smaller chunks called subroutines or sub-procedures. This is done so that they become easier to read and also because the parts of the algorithm can be reused. Thus, we can define an algorithm as a set or list of instructions for carrying out some processes step by step. Example 3. Write an algorithm to add two numbers. 1. Start. 2. Input number 1. 3. Input number 2. 4. Add the two numbers. 5. Print the result. 6. Stop. So, now you know that you need to follow a number of steps to complete any task. But to solve any problem, you have to follow the steps in a particular orderly way. Similarly, you need to write programs in computer language to solve any problem in a computer. Therefore, one needs to develop an algorithm before writing a computer program to solve a problem using computers. Advantages of algorithm. There are many advantages of writing algorithms for solving a problem. Algorithms are very useful in solving problems. Some of them are as follows. 1. They are easy to understand. 2. They are easy to implement. 3. They describe the steps that should be taken to solve a problem. 4. They help to eliminate any logical error in our problem-solving program. 5. They are independent of any computer language. Flowcharts. Flowcharts are easy to understand diagrams showing how different steps in a process fit together. This makes them useful tools for communicating how the process works and for clearly documenting how a particular job is done. Advantages of flowcharts. First, it is usually much easier to draw a flowchart of a problem and then to write a program directly. Second, flowcharts are an important aid in the development of the algorithm itself. Third, easier to understand than a program itself. Fourth, independent of any particular programming languages. Fifth, it saves time while writing the program. Symbols of flowcharts. To make a flowchart, you need some standard symbols. Each symbol represents a specific type of operation. Let us learn symbols used to draw a flowchart. Terminal box. It is an oval-shaped box, also called start or stop box. This box is used to represent the beginning and the end of the flowchart. It is an oval-shaped box. When it is used in the beginning, it is called start box, and at the end, it is called stop box. Input or output box. The shape of this symbol or box is like parallelogram. It contains instructions which are used to read or write the information. That is, all input or read and output or print operations of the specific problem. Process box. This rectangular box denotes computational instructions. Flow lines. An arrowhead line is used to connect different boxes of the flowchart. The direction of the arrowhead shows the direction of flow of data information. Decision box. It is a diamond-shaped box used to represent the conditional operations for checking or applying any condition in the program. For example, if A, B, then print A, else print B. Connector. If you need to connect to another page or another section of the chart and can't draw a line, you can use a circle. Creating a flowchart. To create a flowchart, first categorize the steps of algorithm as input, process, or output statement, and then using the boxes, connect them to form the chart. For example, to add two numbers. 1. Start. Terminal box. 2. Input two numbers. Input or output box. 3. Add the numbers. Process box. 4. Print result. Input or output box. 5. Stop. Terminal box. Start. Input A, B. Sum equal to A plus B. Print sum. Stop. Let's take some more examples of the flowcharts. Draw a flowchart to send a letter by post to your friend. Start. Pick a blank paper and a pen or pencil. Write letter. Put it inside an envelope and close it. Write the address of your friend on the envelope. Do you have stamps? Yes. Stick the stamps on the envelope. Do you have stamps? No. Buy stamps. Stick the stamps on the envelope. Drop the letter into a letterbox. Stop. Algorithm and flowchart to find the greatest number out of two numbers. Algorithm. 1. Start. 2. Input two numbers A, B. 3. Compare the two numbers. If A is greater than B, then go to the next step. Else go to the sixth step. 4. Print A is greater. 5. Stop. 6. Print B is greater. 7. Stop. Flowchart.